All right. Thank you for the introduction, and thank you for coming and making it through to the last session of this conference. So my name is Mariia Arseenko, and I'm working for CRM Group. And I hope I can bring you a few fresh ideas about electronics printed directly on 3D for large area and harsh environments applications. First of all, what is CRM Group? We are a research center, and CRM goes for research center in metallurgy, so we are basically experts in metallurgy. We are located in Belgium in 2 locations in Liège and Ghent, and we are about 300 researchers working on anything related to metals. We are presented worldwide, and we have our unique skills. We do prototyping, design, and realization of our projects, and also licensing of in-home built solutions for our clients. Here you can see almost every client of us, well, not all of them. We have 350 clients a year and working directly for them, but also with European funding, of course, and local Belgian fundings. And today I present a department which is shortly called Smart Surface Solutions. So as we work with metals, we also work with their surfaces, and we work in all these kind of industries. And since today we are talking about printed electronics, we are working on printed electronics on metallic surfaces mostly. Of course, we are doing all kind of what we call functional cell or functional units. So we are doing circuit boards, heaters, thermocouples, different kind of sensors and antennas. But not less important, we connect it into the matrices, which we can, where we can individually control every single unit, read data with our multi-layer technologies and adaptable resolution. And after that, we also work on adaptation of those matrices to our surfaces. Of course, it can be something in 2D, like roll-to-roll process, but also on 3D, and all together with producing the part by, for example, SLM processing. And I will give you several examples of that. So an example of this combined approach you can see, for example, here where we were developing a smart camouflage for one of our customers. So here we started from, of course, designing our heating cell, but then we connected these cells into the matrices, and with individual control, we could make any kind of patterns which can be observed by ER camera. Here you can see an example of what we've done. So here we have, I don't know if you can see, our innovative hexagonal cell design. We adapted it to a 3D body, combined actually both solution, which is passive and active. Active is the solution which is done by printed electronics, but passive solution which is done by paint, where we can actually play with emissivity. And combining these 2 solutions, we can give a certain pattern for ER camera. But this technology is done by screen printing on a rigid polymer surface, and I'm not going to talk about that today because there are many talks about that. As I mentioned, we work mainly on metals. And the first problem which you always need to solve when you print electronics on metals is a dielectric layer, because you need to isolate this metal. And then on top, of course, you can print your circuit. But of course, it's more complex than that, and when you want to produce something of this kind in 3D, you need to think about dielectric layer, all components which you would like to place there, and also some insulation and protective layers. We can solve this problem in CRM Group. You can see an example, and like that we have access to any kind of shapes in metal which are robust, smart, with direct integration in a continuous process. Talking about the dielectric layer, we have our developed wet coating pilot line where you can directly receive this kind of sheets covered by a dielectric layer and on top, and you can already print and you can integrate it into your roll-to-roll machine. Another opportunity is this kind of pilot line with vacuum coating, where we have a designed section for every single step of our processing of our surface. And indeed, again, it's roll-to-roll and can be integrated into your machine, theoretically. However, today I'm talking about 3D.